The existing subsea water main for portable water supply to Pulau Ketam was laid across the shipping channel between Pulau Indah and Pulau Kelang back in 1992 using the conventional submarine dredging method, which resulted to 5 serious leakages and damages at the subsea water main, which has disrupted the water supply to Pulau Ketam. In order to provide a temporary solution, the Water Supply Department had to spend a substantial amount of money to provide temporary water supply and restore the water supply system upon each disruption. Today, 19% of physical water loss from existing subsea pipelines from Pulau Indah to Pulau Ketam was recorded. In order to create a long-term solution, a feasibility study has deduced that horizontal direction drilling, or HDD, is the preferred method to install pipeline underneath the Strait of Kelang due to its economical and environmentally friendly approach. With the HDD method, the construction cost for laying the subsea pipeline could save up to 33% compared with open-cut trenching. Apart from that, a study has revealed that a total of 785,000 cubic meters of soil excavation is required for conventional submarine dredging, compared with HDD, which requires only 894 cubic meters of soil excavation underneath the seabed. This proves that by using HDD, it could eliminate large volumes of soil excavation while providing a deeper depth of pipe cover. Furthermore, the advantages of HDD include no disruption to the seabed or the navigation shipping channel, virtually no impact to the environment or marine ecology, protection of product pipes inside the HDD tunnel instead of exposed to the threat of anchoring activity in the sea. Upon completion, there will be a minimal impact to the landscape and surface restoration. In view of this, the Water Supply Department under the Ministry of Energy, Green Technology, and Water Malaysia has undertaken the replacement of water mains to Pulau Ketam, consisting of a 5,850-meter pipeline. One of the key features of this project is to replace a submarine water main with an outer 406mm diameter steel pipeline that runs between Pulau Indah and Pulau Kelang using the horizontal directional drilling method. The 1,960-meter stretch of pipeline, which is minimum 16 meters below the riverbed at the Strait of Kelang by HDD, was completed on the 14th of March, 2015. The HDD specialist contractor selected the Maxi HDD drilling rig, complete with a set of drilling accessories with the capacity to handle up to 3 kilometers of pipeline within the pipe size range of 914 millimeters. This set of drilling plant and machinery is proven to be more than suitable for the intended HDD works. An entry point was designated at Pulau Indah while the exit point was designated at Pulau Kelang. The installation of pipeline by means of HDD was conducted in 4 processes. The 4 processes include wash pipe conductor steel casing installation work, 311mm diameter pilot hole drilling, hole enlargement reaming, and pipe pulling. First process, wash pipe conductor steel casing installation work. Before the 311mm diameter pilot hole drilling was commenced, a 406mm diameter wash pipe with a total length of 200 meters was installed from the entry point to minimize the buckling effect of the drill stem during pilot hole drilling. The wash pipe was also served as a conduit casing during the pilot hole drilling operation. Second process, pilot hole drilling. During the pilot hole drilling fluid was pumped through the drill pipe and drill bit. The suspended cuttings inside the drilling fluid were then flowing through the annulus of the tunnel and then from the borehole at the surface separation system. The function of drilling fluid is to suspend and transport cuttings out from the drilled tunnel, serves as a lubricant and coolant to the drill bit and its assembly, namely bottom hole assembly, BHA, to stabilize the drilled tunnel, and to suspend the drill cuttings during static periods. The steerable drilling assembly consists of sets of drill pipes along the designed drill path guided by a drill head with a locating system behind it. A downhole survey shot was taken to record the positions of the sensor probe in X, Y, Z axes upon completion of drilling for each joint of drill pipe. The same process was done continuously until the exit point. After the drill head was successfully punched out at the proposed exit point, the drill head and its assembly was dismantled from the drill string. The high accuracy of the punch-out was remarkable, which was within 2 meters from the target point. This was followed by the preparation of working platforms at the exit point by mobilizing a set of drilling barge. This drilling barge consists of an HDD rig, which served as a pulling device to pull the product pipe from the entry point towards the exit point. Once the barge was positioned in place, the drill barge will be ballasted with water until it sits on the base of the ground. To provide further security, the drill barge will be anchored. The spud will be installed and tied to the barge. For logistics and mobilization, a landing craft transport was used to transport material between the entry site and the exit site. The nearest jetty was utilized as a station for material transport between the entry site and exit site. Third process, hole enlargement and reaming. For the third step, the completed 311mm diameter pilot hole was enlarged to a final hole size diameter of 762mm by pulling back a constantly rotating back reaming tool. The hole enlargement process was conducted in 3 phases, namely 457mm, 610mm, and finally 762mm. As the reamer was being pulled and rotated by the drill rig, drill pipes were continuously added behind the reamer. All reaming tools are equipped with cutters and nozzles to hydraulically and mechanically remove the surrounding soil by pumping the drilling fluid through the drill string. At the end of the third step, the back reaming tool was pulled an additional pass of 762mm into the tunnel to ensure the tunnel is cleaned before pulling in the product pipe. Fourth process, pipe setup and pipe pulling. In the fourth and last step, the product pipe was pulled in. Prior to pulling in the product pipes, the pipes were welded by qualified welders and were sandblasted internally to remove internal welding slag. All welded pipe joints have undergone non-destructive tests, or NDT, to ensure the integrity of the welded joint. Once the product pipe's welding and NDT were completed, hydrostatic tests were carried out to pressurize the product pipeline to the design parameter. Subsequently, internal coating and shrink sleeve as external coating on the welding joints were carried out. A camera is used to access the inside of the coated pipe for each completed joint to ensure it is free from damage. The final process of the product pipe preparation was conducting a holiday test to ensure the entire pipeline has 0 defects. The inspected and approved product pipeline was placed onto the pipe rollers at a predetermined profile. Due to the working space constraint, the product pipeline was prepared in 2 sections, and these 2 sections will be jointed as a golden joint. Once the first section of product pipeline was pulled into the final 762mm borehole. As the first section of the product pipeline was ready for pulling into the final 762mm borehole, a swivel was installed between the pull reamer and the product pipe to prevent the rotation of the pipe pulling assembly applied to the product pipeline during the pipe pulling process. The product pipeline was adjusted and lifted according to the punch-out gradient and permissible bending radius of the product pipe. Once the entire pipe pulling setup was ready, the pipe pulling process was started from the entry site until the end of the product pipe reached the surface of the exit point. The HDD method for the installation of the subsea pipeline from Pulau Indah to Pulau Kelang has been taken into thorough consideration to meet the requirement to adopt a greener approach in the design and engineering by reducing energy consumption during construction. The HDD method conserves and minimizes the impact on the environment and corroborates the local contractor's capability for innovation with a long-term, greener technology solution.